Hello, hi, this is Nagarajan. Okay, so today we are going to discuss about the reduction of interference. Okay, reduction of interference. In the previous class, we discussed about what are the sources of interference. Okay, the main source is current. Okay, current through the body. Okay, that is patient, and current through the amplifier, that is the equipment, then current through the measuring cable, okay, that is probes, okay, probes, and finally magnetic interference. These are the four majorly classified interference that are taken into account. Now it should be reduced. The interference should be reduced. If it is not reduced, then that will reflect on the outputs. Okay. If that is reflected on the output, then that will vary the readings. Okay. So if the reading is changed, then obviously the doctor will go for different prescriptions. Again, that will reflect on the patient. So for a good and perfect and accurate result, this interference has to be reduced. Okay, now let us go into the topic, interference reduction. So when compared to the other topics, what are the sources of interference, we can conclude to a certain points. Okay, because we cannot go and search for all the sources, and we cannot go and search for some remedies for all the sources, and it is very tough. Okay, excuse me. So if you go and search for the solution for each and every individual problem, then it leads to the complications. So what we can do is we can segregate the source. Okay, the source for all the problem is the common mode voltage. Okay, the high common mode voltage. Okay, this high common mode voltage can be reduced. Okay, how it can be reduced? The first way is we can add the common mode rejection ratio. Okay, the common mode rejection ratio of amplifier. Okay, the common mode rejection ratio amplifiers with high limitations can be can be connected. First point. Next point, this high voltage, common mode high voltage, which creates interference, okay, can be reduced by adding difference, okay, by adding different impedance electrode, okay, different impedance electrode. So that is why it is clearly discussed in right leg driven ECG with right leg driven circuit in high CMRR. Okay, and it is also discussed that this reduces the common mode voltage amplitude both in isolated and non-isolated measurement. Okay, therefore this CMRR property, that is character of an operational amplifier, is very good. Okay, so it is that one is showing an good impact on the reduction in interference. Okay, then these features, okay, these features can be utilized to omit the isolation amplifier also. Okay, it is this CMRR feature also reduces the isolation amplifier. Okay, so that we can reduce the components number. Another drawback is this is unstable. Okay, this drawback is an unstable. So power line interference can be reduced. Okay, power line interference can be reduced by proper grounding and following the safety regulations. Okay, even if the patient is excited by the low leakage current, that should not get affected in the reflected in the measuring device. Okay, that has to be noted down. And the next one we are going to look at is reduction of interference current in measurement cable. How it can be reduced in the cables, because the 3-1, okay, current through the body, current through the amplifier. Okay, so both can be reduced by providing a proper grounding from body to the earth. Okay. And reduction of interference in measurement cable can be reduced by two techniques. First one is shielding and second one is guarding. Okay. Shielding is nothing but making the cable, measurement cable, that is enclosing, we can say that one was an enclosing the measurement cable with some common wire, with some which is very flexible. Okay, so here it is given that shield connected to the amplifier is to be common. Okay, that is the common one, and it eliminates the interference current in wires. However, it does not reduce the total level of interference. Okay, then we are going for the guardings. Guardings is, there is also a shielding. Okay, it is also a shielding. When that shield is driven with a signal at inner wire, very carefully note this point. Okay, shielding is a special structure of wire that protects from the interference, and guarding is also a similar one, but along with that shielding, this guarding is also a shielding that drives the inner wire with a small signal. Okay, this creates an virtual capacitance. Okay, this creates an virtual capacitance between the input impedance of the circuit, that is between the cable and the the wire. Okay, so with this we can adjust the input impedance, and it can be made to negligible. Okay, then guarding with the average of input signals. If all the shields are driven with average input signal, the input capacitance is virtually small. Okay, because there exists no potential difference between the shield and the inner wire for these signals. This is a good and compromising method of reducing the interference current in measurement cables. So this is so extremely long measurement cables are avoided. Finally, what the conclusion is: avoid the cables, measuring cables in a lengthy way. Okay, try to make the length less than 1 meter. If it goes more than 1 meter, not even 1 meter, 1 to 3 meters, then that cable again creates some problem. Okay, so that is the point here represented, that avoid long measuring cables. Okay, avoid long measuring cables. So With this, we will conclude this reduction of interference current in measurement cable. Next, we will discuss about this isolation amplifier. Thank you.